Hi class, we are now in the mass percent composition of compounds. So we're going to be dealing with percentage here. So the mass percent composition, or mass percent is the easier way to state it, is we're looking at an element and the element's percentage of that total compound that it's in. So for instance, if we wanted to know how much by percent of oxygen makes up the H2O water compound, we would set it up as such. So here is a general formula. We take the mass percent of the element, whichever the one we're interested in. We take, that's what's going to be the percent here, but the mass of X in a sample. So the amount, whatever the element that we're looking at, the mass of it here, and then the total mass of the sample here. So for instance, if we were interested in oxygen out of H2O, I would add 16 grams here because mass is grams, and I would write 18.02 grams here because that's the mass of water. And then I would times it by 100, and it would tell me the mass percent that makes up the oxygen from that compound. So remember one thing, when we're dealing with percent, it's always out of 100. So when you say something is 39%, that means 39% out of 100. If you're saying 10%, that's 10% out of 100. The percent tells you it's 100. You don't always have to say out of 100. So 50%, it's out of 100. 60, so that's the guideline always. When you use percent, it's always out of 100. And a simple way to understand percentage is you have a part over the whole, and you're looking at the part or parts, and you add the whole at the bottom. So if you're looking at a piece of pie, the pie would be the whole down here, and the parts, how many slices? Let's say there's 8 slices. So let's say you want to take one slice. So you'd write 1 slice here and 8 slices down here. So the part always has to be less than the whole, and the whole always has to be more than the part. So let's do a problem. 0.58 grams a sample of chromium reacts with oxygen to form 0.523 grams of metal oxide. The mass percent of chromium is as follows. So we have a mass percent. We want to know the percent of chromium in this compound. Now we don't need to worry about the compound because the compound's already been given to us. So we don't need to worry about what oxidation state and so forth, how many oxygens are part of this. They've given us the amount of 0.523 grams. They've also given us the amount of the chromium in the sample. So we need to find a percentage of that. So what we have is we have this whole and we have this part in blue. We don't know what this other section is. We just don't know what the percents are. So in this case, we set up the mass of chromium, which is 0.58 grams, which we have it here. And we set up the sample itself, which is 0.523 grams times 100. And chromium makes up 68.5% of this compound. It also gave us the sample mass. This sample mass plus whatever this sample mass is has to equal the total. So if you have something different, then something's off. It has to match up. So this other half is 31.5. So if you just subtract it out of 100, you would determine that this other half of the oxygen content that makes up this compound is made up of 31.5%. And you could subtract this from this, and you could also get this grams. Okay, so we can use mass percent as a conversion factor between grams. So if we're given a problem with percent, we always remember that percent is out of 100. And if it's by mass, we can change this to grams. What do I mean? Well, if you're given a problem with sodium chloride is 39%, you can change this to mass because it's always out of 100. So sodium chloride is 100 grams, and the sodium is 39 grams for every 100 grams of sodium chloride. So you could set it up as a conversion factor if you need to use it this way or you need to use it this way. So if you're ever given percent, do not panic. You can change this to grams if it says mass percent by, or by mass percent composition, something to indicate its mass. And usually, most of the time, if you're given this, it's already it's something that's already known like that you can change it. So in this case, we have these two different conversions. So let's do a problem. The FDA recommends that adults consume less than 2.4 grams of sodium per day. How many grams of sodium chloride can you consume and still be within the FDA guidelines? So we want to know how many grams of sodium chloride. This top saying is 2.4 grams of sodium. So how much sodium chloride can you consume that still falls into this 2.4 grams? And it gives you sodium chloride is 39% by mass. So there it is, by mass, this is grams. So what's given to us? We have 2.4 grams, and we're going to use the conversion factor, which way that works for us. We need to get from grams of sodium to grams of sodium chloride, and all we're given is this amount to start with and this percent. So we set it up with 2.4 grams of sodium. We use the conversion factor that allows us to cancel the sodium out and leaves 100 on top. We can consume 6.2 grams of sodium chloride and still be within this 2.4 grams of sodium per day. That's allowed. Okay, so if a woman consumes 22 grams of sodium, how much sodium chloride does she consume? So again, we're given a 39% sodium by mass, and we're going to set it up. So we have 22 grams. We're going to use the percent given to us, and that means that she consumed 22 grams of sodium, but what she really consumed was 56 grams of sodium chloride. That's it.